and welcome. So in this video, we're going to learn about systems of equations and how to solve a system of equations by graphing. So a system of equations is two or more equations. So when you're given at least two equations, you have a system of equations. A solution to a system of linear equations is the point, so that one point, where the two equations intersect. Now, when you're solving and trying to find the solution of the two lines, there are three possibilities. The first possibility is if you have two lines with different slopes, they're going to intersect in one place, right there. They intersect in one spot, so they have one solution. It would be that x comma y of where they actually intersect. The second possibility that you could have when finding the solution to a system of two lines is you could have two lines with the same slope. So if you look, when we have two lines with the same slope, another word that we could use to describe those is that we have two parallel lines. They never intersect, so we're never going to have a solution. So our answer to this would be no solution. There's no intersection point to have a solution. The third possibility is that you have two lines that are identical. So when you graph those two lines, you're graphing the two lines right there on top of each other. So we actually have two lines. We have this smaller line here, and we have a longer line just to show the difference. But when you have two lines that are identical, you have infinitely many solutions because they are actually intersecting the entire time because they're the same line. Apologize for that very poor handwriting right there, but it's infinitely many solutions. So let's take a look at some examples. We're going to graph the system of equations. So we're going to graph the two lines, and then we're going to find the intersection point, and that would be the solution. So taking a look at our first graph here, we have y equals 2x minus 5. This means that our y-intercept is going to be 0, negative 5. So we can go ahead and plot that. 1, 2, 3, 4, 5. And then we're going to use our slope of 2. So we have 1, 2, point. 1, 2, point. All right, then we want to connect those points with our line, trying to keep it as straight as possible. Then we want to graph our second line. Our y-intercept of this would be 0, positive 5. Because remember, these are in slope-intercept form, so it's y equals mx plus b. So we can graph our y-intercept. So we have 0, 5. And then we have a slope of negative 3. So that would be negative 3 over 1. So we go down 1, 2, 3 to the right 1. 1, 2, 3 to the right 1. 1, 2, 3 to the right 1. Then we can go ahead and connect those points. And if you notice, right there is our point of intersection, this point. So we want to find and pull out the coordinates of that point. So if we look, we're starting at the origin, we're going to the right 2. So it would be 2, and then we're going down 1. So 2, negative 1 is the solution to that system. Then taking a look at example number 2, we can go ahead and graph our first line. We have it again in slope-intercept form. So our y-intercept is going to be 0, 4. We can go ahead and plot that. Then we use our slope of 1/2. So we go up 1 over 2. Or we can go down 1 to the left 2. And then we're going to connect those points. Now, our next equation is not in slope-intercept form. It's actually in standard form. So to graph this, what I would do is convert this into slope-intercept form. So we're going to subtract 2x from both sides. Then we would divide by negative 4. So we get our slope-intercept form of this line would be y equals 1/2 x minus 2. Then we can go ahead and graph that. So our y-intercept is going to be 0, -2. So we would go down 2. And then our slope is 1/2. So we go up 1 to the right 2, up 1 to the right 2. We go down 1 to the left 2. We want to connect those points with a straight line. Now, when we look at this to pull out that intersection point, we don't have an intersection point. What we did have, though, was we had our slope is 1/2, and our slope here was 1/2. So we have two lines with the same slope, and if you recall from above, two lines with the same slope have no solution because they're never going to intersect. And it's shown in that graph that those two lines are never going to intersect. So you can go ahead and pause the video right now and give number 3 a try on your own. We have a line that is in point slope form, and we have a line that is in slope intercept form. So taking a look at number 3, if we have our line equation in point slope form, we could do one of two things. We could convert it into slope intercept form if that's what you choose to do, or you can pull out the point, which in this case would be 3, 2, and you can pull out the slope, which in this case would be 2, or 2/1. So we can go ahead and plot that. 3, 2, and then our slope is 2/1, so we go up 2 to the right 1, up 2 to the right 1, or we can go down 2 to the left 1, down 2 to the left 1, down 2 to the left 1. Then we go ahead and we connect those points. Then we want to graph our second equation, which would have a y-intercept, because it's in slope-intercept form, has a y-intercept of 0, 1. So we go ahead and plot that on our graph. Then we have a slope of 3/4, so we go up 3 to the right 4, or we could go down 3 to the left 4, and we go ahead and we connect those points. So in this case, we can clearly see that there is an intersection between our two lines. It's right here. So we want to find the coordinates of that point. So we find that we're going 1, 2, 3, 4. So we have 4, comma, and then we're going up 1, 2, 3, 4. So our solution is 4, 4. Now, taking a look at our last example here, we have example number 4. Our first equation is in point slope form, so we want to pull off our point, which would be -2, 1, and our slope would be 1/2. So we can go ahead and plot that. We have -2, 1, and then our slope is 1/2, so we up 1 to the right 2, up 1 to the right 2, up 1 to the right 2, and we can connect those points. Then our second equation is in standard form. So you could go through and you could plot this using your x and y intercepts, or you can convert it into your slope intercept form, which is what I'm going to do. So that would give me y equals 1/2 after I subtract x and divide by -2. So I get 1/2 x plus 2. So then I'm going to go ahead and plot that. So my y-intercept is going to be 0, 2. So I start at 0, go up 2. And then my slope is 1/2. So I'm going to go up 1 to the right 2. Or I could go down 1 to the right 2. And I'm going to switch colors here just so it's a little easier to see. If I connect those 3 dots that I just created with my red line, you'll see that they are the exact same equation of the line. It's the exact same line. So we're not going to have just one intersection point. What we have in this case is our infinitely many solutions. So remember that when you're graphing systems of equations, you can have three possibilities. You can have ones where they actually do intersect and you pull that point off. You could have systems where they do not ever intersect and their lines are parallel, so you have no solution. Or you could have the possibility of graphing the same line where they intersect at every single point, so they have infinitely many solutions. Remember that if you have any questions about systems of equations and how to solve those, please talk to your teacher and they will help you through it.